problem number 19 from section 4.3 in our book, and we're asked to find all the points of inflection for this curve. We'll start by taking the first derivative, and we'll do the quotient rule, bottom times the derivative of the top, and I've already made a mistake. Let's try that again. Please call out as soon as you see me making a mistake, please. I want to make sure that we don't end up getting
plus one.
Plus one. Thanks, Vince. All right. Times top times the derivative of bottom, which is 1, all over bottom squared. So far, so good. Now we're going to have to expand. We're going to have to expand this. So we're going to end up getting 3x cubed minus 4x squared plus x minus 6x squared plus 8x minus 2. And then let's distribute this negative sign through all those terms, and we get negative x cubed plus 2x squared minus x plus 1. And this is all over x minus 2 squared.
Yeah, interesting.
Now, let's find common terms and collect them. In red, this cubed term and that cubed term gives us 2x cubed. In green, all the squared terms, squared, squared, and squared. So we got a negative 4, negative 6 is a negative 10, plus 2 gives us negative 8x squared. All right? Next, in blue, the x terms. Positive 1 plus a positive 8 is positive 9, minus 1, positive 8x. And then our constant terms, negative 1 plus 1 is a negative 1. And that's all over x squared, or x minus 2 quantity squared. All right? That's the first derivative.
Number 2.
Now, side note here. I was doing this problem with someone earlier today. I thought the problem was find the intervals of increasing and decreasing. So I tried to find zeros for this. Oh,
No.
bad.
No bueno.
All right. So, because someone got that written down? Because what I'd like to do is I want a fresh sheet of paper to do the next line.
Yeah, I got it.
All right? You got it down?
Yeah.
All right.
Whoa.
Yes.
No, we know that one.
Sorry.
Do it again.
So if y prime is equal to 3x,
Whoa.
2.
2x to the third. 2x cubed.
2x cubed minus 8x squared plus 8x plus 1
Minus
minus 1
Minus 1.
over x minus 2 squared. That means y double prime. Okay, let's give it a whole lot of ugly.
Yeah.
Bottom
Again. Wait.
times the derivative of the top.
Actually,
6x squared minus 16x plus 8 minus the top
squared.
thank you, times the derivative of the bottom.
Oh, never mind. Yeah, we distributed the
And that's all over to the fourth now. Continuing on, we got to expand this first.
Why don't you cancel out?
Oh, who is so smart? Who said that? Gunnar.
I was wondering.
Gunnar has now made it into calculus immortality because his name has now been mentioned.
I was Nathan Malonis.
All right, so we can lose
One of them.
this one and one of those. And that's now a cube. Oh, that makes things a little bit easier. All right, we still have to expand this out, and we're going to get 6x cubed minus 16x squared plus 8x minus 12x squared plus 32x minus 16. And then we got to clean this still up, and we're going to get a negative 4x cubed. Well, we got a negative sign here, and then we got a 2, and we got a 2 there. So everything's going to be doubled here, and we're going to have a negative. So negative 4x cubed plus 16x squared minus 16x plus 2. And I no longer need that parenthesis. So get rid of that. And then all of this, of course, is still over that. So let's collect our common terms. First in red, the cube terms. 2x cubed. Next in green, the squared terms.
I get 12x squared.
Okay, let me get that right. So it's negative 26 minus
No, it's
16.
16.
Negative and positive.
So negative 28 plus 16.
Or just
The
negative
two
16
16s cancel out.
minus 12.
Oh, these two, okay, oh, yeah, I see it now. These just can't,
Oh.
so leaving us negative 12, x squared. Okay, 40x minus 16 is 24x.
Yep.
And then our, oops, I forgot to circle those. Oh, no, yeah.
Yes.
We got them all those?
Yep, you're good.
40 minus 60, okay. And then our constant term is going to be negative 14.
Yes.
And all of that is
Simplify that.
there.
I gave up at that.
We can take out a 2.
This is why we need Wolfram Alpha.
We can take out a 2, and we get 2 times x cubed minus 6x squared plus 12x minus 7 all over x minus 2 cubed. Now at this point I'm going to say, if this class was 5 years in the past, we would simply say, you know what? The thing that causes the 0 in the numerator of that expression, if it is a whole number, it is going to be in the form either plus or minus 7 or plus or minus 1, if it exists. And it's if it's a rational solution. And we would spend a bunch of time asking whether these particular rational values make this true or not. All right? But we're not living 5 years ago.
What?
We're living today.
We were living 5 years ago.
Yes.
We were living 5 years ago. But right now, it's not 5 years ago. Although the person who watches this video in the future, it will be the past. Never mind.
Okay, we don't want another 12-minute video.
Probably would have been.
Having fun with that iPhone 6 yet?
Remember the name of our own room. Just do a favor, you gotta say 6 years ago because you're not gonna watch it for another year.
That's true.
So you know that iPhone 6, it's really nice, isn't it?
Actually, I mean, if we're gonna talk about historical things, you can all bemoan the 4-game sweep of the Tigers that happened yesterday.
Let's go, Red Wings.
If they have a season. Of course, in the future, they'll know whether they had a season or not.
And then they'll laugh at us as we wander in our ignorance. But then when we're wrong, it's kind of like sunset.
Okay, but what we really want to do at this point is we want to use the calculator. We want to use the calculator as a good tool to to see if we can find the answer to the question, what are the zeros of that y double prime? Now, if I go into calculator mode, sorry, I don't want calculator mode. What was I talking about? I want a graph mode. Now, there is a way to do this in the calculator mode using the solve function. But the reason why I'm not going to do it that way is because of the 5 things that the College Board says that you must be able to do on a calculator. One of them is to solve for zeros using graphs. So what I'd rather do is I'd rather graph out this function and deal with it that way. So here's me putting in the function. And boy, I really hope I don't make a mistake. Close paren, and then divide by open paren, x minus 2, close paren to the 3rd power, close paren.
Why did you bother to take the 2 out?
Oh, no, you
Whoa,
messed
whoa,
up.
whoa, hey. Okay, get
Yeah.
We're good.
Close paren. Now, are we good there? We got stuff on the top.
Graph that really equation. Yep. Graph that.
All right.
Oh my god.
Wow.
Okay. And the graph of this suggests that there does seem to be a 0 there. Okay. Let's find out where that 0 is. And it's menu, analyze graph, find a 0, and it's in that interval. And there it is. It says the 0's at 1.
At 1.
Yep.
So you plug 1 in.
So when you plug in, well, actually, the graph actually tells us everything we need to know. It tells us that there is a sign change because you can see the second derivative function change from positive to negative at 1. Also, because the second derivative function is positive when we're less than 1. That means that the function is positive. That means it's concave up on the interval from negative infinity to 1. This function is negative afterwards.
Why is it concave up though? It's going.
Because that's
Right. Remember, this is the graph of the second derivative.
Yeah.
Okay. And we recall.
The function is.
We recall that when a second derivative is positive, it's a concave up.
Okay.
This second derivative function is positive,
Yeah. Got it.
so the original function is concave up on the corresponding interval.
Right.
Concave down here. What's going on at 2?
There's a vertical asymptote.
There's a vertical asymptote in the second derivative function. There's also, if you look back here at the original function, the function is not defined at -2, and there's actually vertical asymptotes there as well.
Wow.
We have no point of inflection where seemingly there's a sign change from negative to positive here because there's no point on the graph at x equals 2.
Yeah.
All right. Now, we have summarized the point that gotten to the point we see the sign change in the second derivative at 1. The point of inflection then still needs to be found, and that is what is the value of y at 1? So what is the value of 1 cubed minus 2 times 1 squared plus 1 minus 1 over 1 minus 2? So that's 1 minus 2, those two cancel out, over -1, and there's our 1. So the point inflection is the point 1, 1.
Oh wait, no.
Okay, so the answer is correct. Yeah.
It's insane. Absolutely insane. No, I'm really getting caught up on the 3 plus 3 part.
It's still recording.
It's an anti.
Go back to integrals.
It's an asymptote.
Integrals are fun. So much easier.
All right,
I
now,
want this class to be
last part of this problem.
That's why I do a lab every day.
The last part of this problem, I want to handle this way. And that is, at some point when you're doing this problem, you may have gotten overwhelmed with just getting to the point where we have the second derivative.
Yes.
I just want to remind you that the, no, I don't want there. I want this. I want the template menu. In the template menu, we have the ability to ask for the second derivative. So, oh, undo. No. Control.
What are you doing? Z.
There we go. So if I go to this mode and put in second into a fraction x cubed x cubed down minus 2x squared plus x minus 1 all divided by x minus 2. Now I tell you this not because I expect you to do this on the test. In fact, this would probably be something that they wouldn't allow you to do on the test, on the AP exam. Because the people who don't have the CAS calculators, you would have an unfair advantage over them. Okay? But I want to expand the idea beyond what goes on in this classroom, is that you are you're learning calculus so that you can use it as a tool in other classes. Physics would probably be the biggest example. Okay? And as you go higher and higher up, tools like Wolfram Alpha or the engine built into here are useful tools. It's like, you got to remember, we only do this because it's useful for something else. And no matter what way we get the answers, eventually, all it's going to be matter is that we got the answer. And then hopefully be able to apply it properly. While we're at it, by the way, menu, algebra, solve, this equal 0, comma, x. Oh yeah, I guess there is a place for this.
Big mom, oh my god.
Now, please note, what doesn't this solution tell us?
It doesn't tell us where the point of inflection actually is. Tangent.
Indeed, and it doesn't even tell us that there's a point of inflection with an x coordinate of 0. It tells us that there's a 0 in the second derivative. The graph tells us that at that 0, there's a sign change. So even though we can find that value of the 0 in the second derivative, it still doesn't help us answer the question.
What about x equals 2? Shouldn't there be something weird there?
There is.
Oh.
This is asymptote.
You're right.
All right. That completes our recording
Oh, God.
of number 19.
Goodbye.
Hello. Reminding you to report some other special message. Hello.